So today we are going to see about that carbon and its compounds chapter. So occurrence of the carbon. So the carbon is found in the atmosphere inside the earth's crust and is all living things. So it is present in the fuels like in our day-to-day life we are using so many things like wood, coal, charcoal, coke, petroleum. So in all these stuffs the carbon is the important ingredient. So the carbon is present in compounds such as carbonates, hydrogen carbonates, etc. And also the carbon is found in the free states such as the diamond, graphite, fullerenes. So this diamond, graphite, fullerenes are nothing but the allotropes of the carbon. So the allotropes means so the same atom, it consists of only the same kind of the atom, but the arrangement of the atoms will be different in each one. That we call it as a allotropes. Bonding in the carbon, the covalent bond. Okay, so usually the covalent bond is nothing but the sharing of electrons between the two atoms in the outermost shell. So that we call it as a covalent bond. This covalent bond will occur in the two non-metals. So they will do the sharing of the electrons. The atomic number of the carbon is 6. So its electronic arrangement is 2, 4. So in the first shell, the 2 electrons will occupy. In the second shell, the 4 electrons will occupy. It has it has the 4 valence electrons. So it can attain the stability by gaining the 4 electrons or losing the 4 electrons or sharing the 4 electrons with the other atoms. So now the carbon is having everything will be the 4. If it has to gain, it should be a 4, or if it has to lose also it's a 4 electrons. So instead of gaining and losing, it needs a lot amount of the energy. Carbon always involves in the sharing of the electrons with other atoms. So usually it will do the covalent bonding. It's very less you can see it in the ionic bonding. It does not gain 4 electrons because it is difficult for the 6 protons to hold the 10 electrons. It does not lose the 4 electrons also because it needs a large amount of energy to lose the 4 electrons. So it's always share the 4 electrons with the other atoms to attain the stability. So to attain the stability in the sense, so in the outermost electrons, it will attain the inert gas configuration that is nearest to the carbon is neon. So the neon has 8 electron in its outermost shell. So when they are sharing the 4 electrons, it will attain the inert gas configuration. So the valency of the carbon is 4. So it is a tetravalent. It means that tetravalent means it can able to make a 4 bonds with the other atoms. So here one, here one, here one. So it can able to make the 4 bonds. The formation of the covalent bonds. So the covalent bond is nothing but the sharing of electrons between the atoms, especially the non-metals will takes place in this. The sharing of the one pair of electrons, if it is a sharing of only one pair of electron, that we call it as a single bond. Suppose if it's sharing the two pair of electrons with one atom, it forms the double bond. If it shares the 3 electrons with this one atom, that it forms the triple bonds. So the formation of the single covalent bond in the hydrogen molecule. So the hydrogen is the first element in the periodic table. So it has atomic number 1 and also the electronic arrangement is also the 1. It has a valence electron 1. So hydrogen wants to attain the stable noble gas configuration. So it needs one more electron to complete the outermost shell. So it is a non-metal, so it always undergoes the sharing of the electrons. It, so what it will do, so this is one hydrogen atom, this is one hydrogen atom. So each hydrogen atom is having the one electron in the outermost shell. So when they are trying to make the bond, so this hydrogen atom will give one electron, this hydrogen atom will give one electron, so both will make a bond. So hydrogen, single bond hydrogen. So this we call it as a single covalent bond because it shares one electron to the other atom. So it's a normally we call it as a H2 molecule. Hydrogen always occurs in the state of the H2. It's a diatomic molecule. Next one is the formation of the double covalent bond in the oxygen molecule. So the oxygen is present in the group 16. So it has a atomic number 8. So the electron is also the 8. So the first electron, the two electrons occupy the first shell. The 6 electrons will occupy in the second shell. So now it needs 2 more electrons to complete the outermost shell. So what it will do is, this is the oxygen atom. So it's having a 6 electrons in the outermost shell. So this is the another oxygen atom. It is also having the 6 electrons in the outermost shell. So this oxygen also need 2 electrons. This oxygen also need 2 electrons. So this 2 electrons it has to share, and these 2 electrons it has to share. So finally it will share the 4 electrons total. So it makes a double bond in between the two oxygen atoms and it forms the O2. Again, oxygen is also the diatomic molecule. Next one is the formation of the triple covalent bond in nitrogen molecule. So the nitrogen is present in the group 15. Its atomic number is 7. So the number of electrons is 7. So the electronic configuration of the nitrogen is 2, 5. So out of the 7 electrons, the 2 electrons will occupy in the first shell. The remaining 5 electrons will occupy in the second shell. So now the nitrogen needs 3 more electrons to complete the shell. So if the nitrogen needs 3 more electrons, it has to share the 3 more electrons from it. So 1, 2, 3, 4, 5. So it has a 5 electrons over here. So out of the 5, the 3 electrons it has to share with the other atom. The other atom is also the nitrogen. So this nitrogen also needs 3 more electrons to complete the outermost shell. So it also has to share the 3 electrons with the other atom. So finally, so this nitrogen is sharing the 3 electrons. This nitrogen is sharing the 3 electrons. So it makes the triple bond N, triple bond N. It's a N2. So this is the triple covalent bond. So the nitrogen also highly reactive as an atom, but the nitrogen N2 is a inert. It is actually a inert. It does not react at the room temperature because it's having a triple bond in its structure. So why it is inert? Because we have to supply the lot amount of the energy to break this three bonds. That's why it is inert at room temperature. So at high temperature, it starts reacting it with the other atoms. Okay. So now this is the hydrogen molecule, and so the hydrogen is having a 1 electron in the outermost shell here. So this is another hydrogen atom. This also has a 1 electron in the outermost shell. So both wants to attain the stable configuration. So both shares 1 electron each. So this is the single covalent bond. So between the hydrogen atom, H single bond H. Next one is the F2 molecule. So the F2 molecule is each fluorine is having atomic number 9. So the number of electrons 9. So out of 9 electrons, the 2 electrons will be present in the first shell. The 7 electrons will be present in the outermost shell. So it needs one more electron to complete the shell. So this fluorine atom also needs one more electron to complete the shell. So both fluorine atoms share the one electron each and it forms the bond F single bond F. Next one is the oxygen again. So here this is the formation of the carbon dioxide molecule. Okay. So now here oxygen is present in the group 16. So it is having a configuration 2, 6. So the 6 electrons present in the outermost shell over here. It needs 2 more electrons to complete the shell. Carbon atom is present in the group 14. Carbon is having the atomic number 6. So the 2 electrons present in the first shell, the 4 electrons present in the second shell. So the carbon is a tetravalent, we know that. So carbon can able to make the 4 bonds. So oxygen can able to make the 2 bonds. So these 2 electrons will be shared by the one oxygen atom, and these 2 electrons will be shared by the one other oxygen atom. So carbon needs 2 oxygen atom to share the 4 electrons. So carbon here, the 2 electrons it's shared with one oxygen atom, and it's sharing the other 2 electrons with the other oxygen atom. So it's making the double bond. So carbon is making the double bond with one oxygen, and here the double bond with the other oxygen atom. So it's a linear molecule. Next one is the carbon tetrafluoride. So fluorine is having a atomic number 9. So the splitting of electron is 2, 7. So 7 electrons are there in the outermost shell. So fluorine wants to attain the stable outermost configuration. So it needs one more electron to complete 8 electron it needs, but here it's having a 7 electrons. So it's looking for the one more electron. Now the carbon is having a 4 electrons in the outermost shell. So carbon can able to share the 4 electrons at a time, but fluorine can able to uh, share the one electron. So each of electron will be shared by the 4 fluorine atoms. So the carbon is sharing the one electron, one fluorine atom is sharing one electron. So carbon is sharing here. So like this, the carbon can able to make the 4 single bonds with the 4 fluorine atoms. So it's a CF4. Okay. So this is the electron dot structure. So this is the CH4 is nothing but the methane molecule. So here again, the carbon is having a 4 electrons, 1, 2, 3, 4. Hydrogen can able to share one electron at a time. So 4 hydrogen needs to make a bond with the one carbon atom. So the hydrogen is sharing a one electron with this. So here one bond. So C single bond H. And here the carbon is giving one electron. The hydrogen is giving one electron. So here both makes a bond over here. And here the carbon gives one more electron. Another hydrogen atom gives one electron. So both makes a bond here. Here the hydrogen is giving one share one electron, and carbon is sharing one electron. So both makes the C single bond H. So totally the carbon can able to make the 4 bonds with 4 different hydrogen atoms. So the molecular formula for the methane is CH4. Next one is the ethane. Ethane molecule. The molecular formula for the ethane is C2H6. So there are 2 carbon atoms and 6 hydrogen atoms are present in this. Okay. So in this case, there are 2 atoms are present in the ethane. One is a carbon, another one is the hydrogen. So the which one is the central atom we have to find out. The one which can able to share the more electrons, we have to place it in the middle. So here the carbon is the tetravalent. So we have to place the carbon in the center. So then the hydrogen atom we have to make the bonds with the carbon atom. So C is single bond C. So each carbon atom can able to make the 4 bonds with the other atom. So first we have to write C single bond C. Then we have to make a hydrogen atom sharing the electrons with the other carbon atoms. So the carbon, one electron is shared with one carbon atom here, and the other electron with the hydrogen here, other electron with one more hydrogen. So each carbon atom is making a 4 bonds, one with one carbon and other 3 with 3 hydrogen atoms. Here also the same thing. This carbon atom is sharing the 1 electron with one carbon, the 3 electrons with the 3 different hydrogen atoms. So all are making a single bonds. Next one is the formation of a very large number of the carbon compounds. The carbon forms a very large number of the compounds, and it can able to make the more number of the compounds, because at a time the carbon is a tetravalent. At a time it can able to make the four bonds with the different atoms. So, and the first one is the catenation. Catenation means it can able to make a very long chain. Example, the polymers. So polythene, polypropylene, so it contains the more than 300 to 500 carbon atoms present in it. It's a very big chain. It also has a very high molecular weight compounds. So the carbon is the only element it can able to make the catenation. Carbon atom can also make bonds with other carbon atoms to form a long chain, the branched chain, and also the closed rings. So this property we call it as a catenation. Because it's having the valency 4, it can able to make the bond with the other 4 atoms at a time, and also it can able to make usually it will make the bond with the hydrogen, oxygen, nitrogen, halogens, etc. So this is a long chain. So carbon single bond. So it will continue. So this long chain will continue. So this is one of the examples. It's like a polymer. It's a polythene. This is a branched chain. So in this branched chain, the carbon can also be able to make here. This is one branch over here. This carbon can able to make a bond with other carbon atom sideways also. So this is a straight chain. So this is a branching it's doing. So this we call it as a branched chain. And this is the closed ring. So the carbon can able to make a bond with the other carbon atom like a chain. It's a closed one. Next one is the hydrocarbons, saturated and unsaturated hydrocarbons. So from the name itself, we can able to identify that what is a hydrocarbon. So the hydrocarbon is nothing but that the compounds have contains only the carbon and the hydrogen. That we call it as a hydrocarbons. Saturated hydrocarbons. Saturated means so the carbon is a tetravalent. So all the electrons are shared by the four different atoms. That we call it as a saturated hydrocarbons. Having all single bonds. In other way, we can say that carbon should have the single bonds with all the four the atoms. That we call it as a saturated hydrocarbons. Example, alkenes. Alkenes are the one which is a hydrocarbon, saturated hydrocarbon having a all single covalent bonds. So its name always end with the ANE, methane, ethane, propane, butane. So from the name itself, we can able to identify that whether it is which family the particular compound is in, whether it is alkene or alkyne. So what is the bonding present in that compound, whether it is a single bond or double bond and all, whether it's saturated or unsaturated. So like that. So the alkenes are usually it's a saturated hydrocarbons. It contains only the single bonds. So the first member of the family is the methane. It's a CH4. So the carbon is making the four bonds with the four different hydrogen atoms. The next member of the alkene family is C2H6. So C single bond C. So it's making a single bond with the carbon atom, and it's making the three single bonds with the other hydrogen atoms. Unsaturated hydrocarbons. So in this unsaturated hydrocarbon itself, it contains the carbon and the hydrogen only, but the carbon is making a double bond with the other carbon atom and triple bond with the other carbon atom. So this we call it as a unsaturation. So or hydrocarbons which contains the double or the triple covalent bond between the two carbon atoms. So examples, alkenes and alkynes. So the alkenes are also the family of the hydrocarbons which contains the carbon, double bond carbon. So their names ends with the ene, ene. Ethene is the first member of the family. There is a no member exists as a methane because methane is the first member of the alkane family. But here in this alkenes, ethene is the first member. So why not methane is not present? Because methane has only one carbon atom. Here, the double covalent bond it has to make. So it cannot able to make the double bond with the hydrogen. It has to make the double bond with the other carbon atom. So that's why the methane is not present. So the first member of the family is the ethene because it has the two carbon atoms. It can able to make the double bond with the other carbon atom. So C2H4, the carbon is making the double bond with the other carbon, and all the here this carbon is having a two bonds over here. The other two bonds are share other two electrons are shared with the other two hydrogen atoms. So this is ethene. Propene. So propene in the sense the double bond means we should not write always C double bond C double bond C. It's not like that. So only one double bond will be present over here. So either you can place it over C double bond C single bond C or C single bond C double bond C. So only one double bond should be present in a straight chain. So here C double bond C. So this is the unsaturated hydrocarbon. Then we have to make double sure that the carbon should is a tetravalent. So this carbon is having a double bond over here. The remaining two atoms are shared with the two hydrogen atoms. In this case, this carbon is making a double bond with this carbon atom and single bond with this carbon atom. So only one electron is left out. That electron is shared with the one hydrogen atom. So it's have 1, 2, 3, 4. Four atoms are present, four bonds are present for this carbon atom. This one is the one bond with this carbon and three bonds with the three different hydrogen atoms. So this is the structure of the propene. Next one is the alkynes. So the alkynes are also the family of the hydrocarbons in which it has a triple bond in its structure. So triple covalent bond it will form. So its names end with the YNE. So here the first member of the family is the ethyne. So as in the case of the alkenes, there is a no methane present. Here also there is a no methane present. Because methane means meth, the word indicates that it contains the only one carbon atom. So with that one carbon atom, we cannot, at least it needs two carbon atoms to make the triple bond. So methane has only one carbon atom. So there is a no compound exist as such. So the first member of the family is the ethyne. The formula is C2H2. So here C one carbon is making a three bonds with the other carbon atom. So remaining one electron is present that is making this carbon is making a bond with the other hydrogen atom. Here also the same thing. So this carbon is making a triple bond with this carbon. So three bonds already it's gone with this carbon. So the other bond is making a bond. This carbon is making a bond with one hydrogen. So formula is C2H2. The next member of the family is propine, C3H4. So what we have to do is C3. So we have to write the C single bond C single bond C. Either if you want to place the triple bond here or you have to place over here. We should not place all the three bonds. Otherwise the middle carbon atom will have the 6. So we should not place like that. Only one triple bond we have to place in the one compound. So now in this case, this carbon is having a three bonds with this carbon. So valency 3 over here, one bond with the one hydrogen atom. In this case, in this carbon, so here it is 1, 2, 3, 4. Already the 4 bonds are already completed. So there is a no more hydrogen bond attached with this carbon atom. Then this carbon atom, so this is a contains one single bond with the carbon. Remaining it makes the single bond with the other hydrogen atom. So 1, 2, 3. C3, there are 3 carbon atoms present, 4 hydrogen, 1, 2, 3, 4. 4 hydrogen atom present. So C3H4. Isomerism. So the isomerism is nothing but So the compounds which is having a same molecular formula but different structural formula. So that we call it as a isomerism. The butane, the formula is C4H10. C4H10. It has the two isomers. So they are normal butane and the isobutane. Okay. So how to write the isomers is, so butane is a, from the name itself we can able to identify that it is from the alkane family because it ends with A and E. So we should be make sure that all carbon atoms should have the single bonds, single covalent bonds. So there are four carbon atoms present. We have to write all the carbons in a straight chain. C single bond, C single bond, C single bond, C. So now first we have to write the all carbon atoms. Then we have to substitute the hydrogen atom. So this carbon atom 1, 2, 3, 4. So the four bonds completely it's filled. This carbon atom is already have a two bonds with the other two carbon. So here one hydrogen, here one hydrogen. Again this carbon making a here one C single bond C and C single bond C. So two bonds already gone with this. So this is making a one bond with one hydrogen here, one hydrogen here. So this carbon is making only C single bond C. So it can able to make the three different bonds with three different hydrogen atoms. 1, 2, 3. So totally 1, 2, 3, 4 C4 carbon and hydrogen 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 hydrogen atoms are present. This we call it as a normal butane. Now the next one is the isomer. So using this molecular formula C4H10, we are just going to rearrange the carbon atoms, but that it should not resemble the same structure. We have to write in a different manner. That we call it as isomerism, right? So instead of writing the four carbon atoms in a straight chain, we are going to write only the three carbon atoms. So we are going to break the carbon atom chain. So instead of writing 4, we are writing 1, 2, 3, 3 carbon atoms in a straight chain. So the next one more carbon atom is left out, that we have to place it in the center of the carbon atom. Okay, so why we should not place in the first or the last carbon atom? Because if you are placing the first or the last, C, single bond C, single bond C, if you are placing over here, again it resembles this structure. So there is a continuation of the four carbon atoms, C single bond C, single bond C. So four carbon atoms are in a chain. But in this case, only the three carbon atoms are having a chain. And the one carbon atom we have made as a branching over here. So this we call it as a isomerism. The four carbon atom is also present and we have to substitute the hydrogen according to their particular valency. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 hydrogen atoms are present and the 4 carbon atoms are present. So the name of this compound is isobutane. Okay. Next compound is a pentane. Pentane is having a formula C5H12. Okay. It having a 3 isomers. Okay. So first one is, so C5. First we have to write all the carbon atoms in a straight chain. So C single bond, C single bond, C single bond, C single bond, C. All the carbon atoms we have to write it in a straight chain. And the hydrogen atoms we have to substitute in a, according to their tetravalency. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has a C5 and the H12 atoms. Next one, the isomer is, instead of writing the 5 carbon atom in a straight chain, we have to write the 4 carbon atoms. We have to cut down one carbon atom. So 1, 2, 3, 4, we have to write the 4 carbon atoms, and the remaining one carbon atom, either we have to substitute in this carbon or in this carbon. Both are same. So we are going to substitute in this carbon atom C. Then we have to place the 1, 2, 3 because the carbon is tetravalent. 1, 2, 3, 4. It's made of 4 bonds with this. Okay. So now this we call it as a isopentene. So we have break down the carbon chain continuity. So instead of making the 5, we have made the 4. Again, we can able to make the one more isomer. So we are going to cut down one more carbon atom and we are going to write the 1, 2, 3. So the 3 carbon atoms in the straight chain. The remaining 2 carbon atoms left out. That 2 carbon atoms, we have to place it only in the middle. We should not place it in the first or the last carbon atom. So we are placing in the second carbon. This is the second carbon. We are going to place one carbon atom here and the other carbon atom here down. And we are placing the hydrogen atoms according to their carbon valencies. So it also is having the formula C5H12. So the name of this compound is neopentane. So the next one is the functional group. Okay, what is meant by the functional group? So now in the hydrocarbons, we are having only the carbon and the hydrogen atoms. So using this hydrocarbons, we can use it only for the burning purposes or something. So what we are going to do over here is, so we are going to substitute the in the place of the hydrogen atom, we are going to introduce the some other nonmetals. Say for example, chlorine, oxygen, so bromine, iodine. So we are going to introduce the one other elements. We are going to substitute the other element. So that we call it as a functional group. So when we are introducing the some other element into the hydrocarbon, so their properties are completely changing. So they are having a different kinds of the properties. Their polarity will be changing. The reactivity will be the different physical properties, chemical properties. Everything will be changing by replacing the one hydrogen atom with the other atom. So that we call it as a functional group. So the atom or the group of the atom which decides the property of the carbon compound. That we call it as a functional group. The first one is the halo. Halo means the halogens, so which is present in the group 17 in the periodic table. Chlorine, bromine, fluorine, iodine. So those we call it as a halogens. Okay. So now here, so we know that the methane formula is CH4. So this is the methane. So now here, the one hydrogen atom, we are replaced it with the chlorine atom here. So this we call it as a chloromethane. So how to name this one is the chlorine is present, so it is a chloro. And this is the one carbon atom, right? So this is the methane, chloromethane. So in this one, this is a bromine atom is substituted. So the formula for the ethane is C2H6. So in the place of the one hydrogen, so we have substituted with the bromine. So bromoethane. So there are two carbon atoms present, so we call it as ethane. Suppose in the case of the C3H7I. So this we call it as a iodo. Iodo. There are three carbon atoms are present, so it is a propane family. So propane, iodopropane. Like this we have to name. So what is the use of substituting this functional group over here is CH4 is nothing but the gas. Okay, but in the place of the one hydrogen atom, we are going to introduce the one chlorine atom over here. So chloromethane is nothing but the liquid, and also it is a polar compound. We are using it as a solvent over here. We can able to dissolve more polar molecules over here. But then CH4 is the non-polar molecule. Is we are just using it only for the burning purposes. It's having a wide number of the uses. So while we are changing the one atom in the particular compound, we are getting a number of the compounds that is having the numerous properties as well as the uses. Next one is the alcohol. So the alcohol is having the functional group OH. So it always ends with the OL. OL means alcohol. So from the name itself, we can able to identify what is the functional group which is present in the particular hydrocarbon. So methanol. So OL. So OL indicates that OH group is present in that. Meth indicates that so there is a only one carbon atom is present. In that carbon atom, we are having the OH group. So the remaining bonds and all we have to satisfy with the hydrogen atoms. Next one is ethanol. Ethanol. So OL indicates that it has a functional group OH and eth. Eth means there are two carbon atoms present. So C2H5OH. So this is the ethanol. Propanol means we have to write with the C3H7OH. So this is a propanol. In the place of the one hydrogen atom, we are going to substitute the OH group that we call it as alcohol. Next one is the aldehydes. So the aldehydes are having a CHO. So in this case, okay, it ends with the AL. So we should not mess up with these two things. OL means alcohol, AL means aldehydes. So in here, the CHO, if the CHO group is present in the compound, that we call it as a aldehyde. Okay, so what is this CHO? So this single bond carbon, double bond with the oxygen atom and single bond with the hydrogen atom. So this we are going to substitute with the hydrocarbons. So methanol. So Al indicates that it contains the CHO. So in this case, meth means only one carbon atom, right? So already it has a one carbon atom. So we should not write one more carbon atom again. So CHO is already has a one carbon atom. So in this carbon atom, it make a double bond with the oxygen and single bond with hydrogen and one more bond we have to place it with the hydrogen. So this methanol is it's otherwise known as the formaldehyde. Formaldehyde. So the formaldehyde is nothing but it's very good. This one, the preservative in as a biological specimens and all. So HCHO is the formula. Then ethanol. So here also Al. So the Al indicates the aldehyde group. So it indicates that it should contain only the two carbon atoms. So two carbon atoms we have to write it. One carbon atom is containing the CHO. The other carbon atom should be balanced with the three hydrogen atoms. So CH3CHO, we call it as a ethanol. The next functional group is the carboxylic acid. Carboxylic acid is COOH. So this is the complete structural formula for the acid. C is making a double bond with one oxygen and single bond with one oxygen and single bond with hydrogen atom. So oxygen can able to make the two bonds. Carbon is having a four bonds, right? So the two bonds with one oxygen and one bond with one oxygen, and in this case the oxygen is making a single bond with carbon and single bond with hydrogen. So now in this case the oxygen is having a two bonds over here. Okay, now we are going to, so this is end with the oic acid. If there are one carbon atom is present, so methanoic acid. If the two carbon atoms present, ethanoic acid, propanoic acid. So like that we have to add the oic acid after the particular hydrocarbon. So methanoic acid. So methanoic acid indicates that it should contain the COOH. Again, already the acid group contains the C. Myth indicates that only one carbon atom should be present. So already the one carbon atom is present over here. So we should not write one more carbon atom. So we have to balance it with the hydrogen over here. So HCOOH. This we call it as a methanoic acid. So next one is the ethanoic acid. So COOH. So eth means there are the two carbon atoms present. So this COOH is combined with making a bond with other carbon atom. There are two carbon atoms present, so it is a eth. So this carbon atom is balanced with other three hydrogen atoms. So this is the ethanoic acid. Propanoic acid means CH3, CH2, then COOH. So this is propanoic acid because it contains the three carbon atoms. So it's a propane group. So it's a propanoic acid indicates that because it contains the COOH group. Okay. Next one is the ketone. Okay. Ketone is also having the C double bond O. See here, there is a basic difference between the aldehyde and the ketone is aldehyde also has a C double bond O. Ketone also has the C double bond O. Now, how to make the difference between the aldehyde and the ketone is aldehyde, one of the bond it has to make with the one hydrogen atom. But the ketone, the C double bond O, both sides it has to make a bond with the carbon atoms only. So that is the difference between the aldehyde and the ketone. So here it is a CHO. Hydrogen should come. If the hydrogen is coming, we call it as a aldehyde. So if the C double bond O is making up with the two different carbon atoms, that we call it as a ketone. So it's N with the ONE. So it cannot able to make, it needs three carbon atom at least, because we cannot substitute with the hydrogen. If we are substituting it with the hydrogen, it becomes a aldehyde. So there is a no meth or eth one. So it's starting from the propanone. So CH3, COCH3. So this carbon atom is making a bond with one carbon atom this side and one carbon atom this side. So this we call it as a propanone. So butanone is, this is the C double bond O. So here it's making a bond with this carbon atom and here it's making a bond with this carbon atom. So this is the butanone. Why we are calling it as butanone is 1, 2, 3, 4. There are 4 carbon atoms present. So it is a but, and the C double bond O, the functional group is present. It's a own. So it's a butanone. Okay. So next one is the homologous series. The homologous series is a group of the carbon compounds having a similar structures, similar chemical properties, and whose successive members differ by the CH2 group. So that we call it as a homologous series. Example, alkanes, alkenes, alkanes. So for example, the first we are going to see about the alkanes. So the alkenes are having the formula CnH2n. So this is the general formula for the alkanes. And we know that ANE indicates that it's a alkane family. Okay. So now in this case, we are going to substitute the N equal to 1. So in this formula, CnH2n plus 2, we are going to substitute N equal to 1. So we will get this CH4. This is the first member of the family, methane. Then we are going to substitute N equal to 2 in this formula. So we will get C2H6. We call it as ethane, the second member of the family. This is N equal to 3. We are substitute over here in this formula. So C3H8. So 3 we are substituting. So 3 times 2 is 6 plus 2, 8. So C3H8. So the butane N equal to 4. So C4H10. This is N equal to 5. So C5H12. So like this, we are having a C1 to C70 alkanes, C70 carbon atoms present. So if we know this formula, we can able to write the any hydrocarbon formula. For example, suppose I would like to write the C10 carbon atom, so which is a alkane. I would like to write the molecular formula for this. So N equal to 10. I'm going to substitute in this formula. So C10H, so 2 times 10 plus 2. So which is nothing but C10H22. So this is the C10 formula. Okay. Yeah. So this is the one. So all these are having the same molecular formula CnH2n plus 2. So that's why we call it as a homologous series. Homologous series means it's having a similar structure and it's having the same chemical properties. So chemical properties in the sense, so all the methane, ethane, propane, butane, pentane, everything we are using it for the burning purposes. So the methane, we know that it is a natural gas, and the propane and the butane we are using in the LPG. In the day-to-day life we are using the cylinders which is used for our cooking. So the LPG, the cylinders contains the liquefied propane and the butane. So the pentane and the hexane are nothing but the petrol. So like this we are having a diesel, kerosene. So everything is a alkenes, which is a saturated hydrocarbons which we are using it in our day-to-day life. So all the alkenes family we are using it for the burning purposes. And also, what is that the whose successive members differ by the CH2 group? What is meaning? So here we are going to take the methane and the ethane. So what is the difference between these two group? So one is the CH4, another one is the C2H6. What is the difference? So C and H6 and H4, so H2. So this is the difference. This difference you can see all over the C70 carbon atoms. So this difference is also CH2. This difference is CH2. So all the successive members is having a difference of CH2. So that we call it, that is the one of the important property in the homologous series whose successive members differ by the CH2 group. So alkanes are the homologous series. So methane is having the formula CH4. The carbon is making a 4 bonds with the 4 different hydrogen atoms. Ethane, ethane is having the formula C2H6. So we have to write the C single bond C and has to make the 6 hydrogen atoms according to the 4 bonds of the carbon atoms. Propane C3H8. So we have to write the C single bond, C single bond, C carbon atoms in the straight chain, and the remaining atoms we have to substitute over here. The next member is the alkenes. So alkenes are having the general formula CnH2n. Okay. So their names always ends with the "-ene". So this is also the member of the homologous series. This also have the same characteristics. It's having the same general, all the members of the family has the same general formula, same chemical properties, and also the successive members differ by the CH2 group. Okay, so now we are going to see that one. So now if we are going to substitute N equal to 2. So in this formula CnH2n, so we will be getting the C2H2 times 2. So C2H4. So this propene will get N equal to 3. So if you substitute, so C3H2 times of 3. So we will get the C3H6. And the next one is the butene. So N equal to 4. So C4H2 times of 4. So we are going to substitute in this molecular formula. So pentane is C5H10. Suppose if you would like to write the C8. So what is the formula for the C8 in the particular alkene means? So we can able to write N equal to 8. So C8H2 times of 8. So C8H16. So this is the formula for the C8 which is in the alkene family. So like this. So there is a no more the one we have to start from only the N equal to 2 because the alkenes are having the double bonds. So the double bonds, it needs at least the 2 carbon atoms to make the double bond. So but the N equal to 1 means it has only 1 carbon atom. So we cannot able to, there is a no more formula exist in the N equal to 1. So you have to start from N equal to 2. Okay. So now C2H4. So now here C double bond C, and here it is a hydrogen we are going to substitute over here. So now in this carbon atom, 1, 2, 3, 4. 4 bonds we have substituted. In this carbon atom, 1, 2, 3, 4. 4 carbon atoms substituted. So the tetravalent is completed over here. Propene. Yeah. So C single bond, actually we have to write like this first. Then we have to write either the double bond here or here. That is your choice. But we have to write only one double bond in the one compound structure. We should not write the two double bonds. So if you are placing the double bond here, we have to make sure that the carbon atoms balancing. So this carbon is already having the two bonds here, one bond with the hydrogen atom like this. So this carbon atom is having 1, 2, 3. Already the 3 bonds are over. The other bond we have to satisfy with the hydrogen atom. So this carbon atom is having the 1 bond here, 3 bonds with the other hydrogen atoms. So we have to be very, very careful while placing the hydrogen atoms, and also damn sure that the carbon atoms having only 4 bonds at a time. That we have to confirm. Butene. Butene formula is C4H8. So the carbon C4 means 1, 2, 3, 4. The 4 carbon atoms we have to write it in a straight chain. The double bond we have to write over here. Now this carbon is having the 2 bonds here, third bond with one hydrogen, fourth bond with this hydrogen. So we should not write one more over here. If you're writing like this, then it becomes carbon is having the 5 bonds. That should not happen. Then this carbon atom, 1, 2, 3. So 3 bonds already over, the 1 bond with the hydrogen atom. Again, this carbon atom is having a single bond, 2 bonds here, one hydrogen above and below. This carbon atom is making a single bond with over here, 1, 2, 3. So 3 hydrogen atoms.